Continuing our introduction to cell respiration, we left off by talking about some key components of aerobic respiration in eukaryotes. We stated that aerobic respiration involves the catabolism of nutrients that eventually result in things like carbon dioxide, water, and energy as our products that we gain from this process. We know that it's a redox reaction full of 30 steps, 30 beautiful steps, 30 enzymes. It starts with glucose, but now we're going to look at the equation more specifically because a lot of exam questions actually utilize this equation and ask you to break it down and label the specific components of it. And that's exactly what we'll do right now. So the equation, famous cell respiration equation, is considered C6, carbons, 6 carbons, H12, 12 hydrogens, O6, 6 oxygens. This is glucose, okay? Another way to say glucose. Plus, and what do we need to breathe in all the time? Why do we need to breathe it in? Well, it's because this is the process that is necessary for us to break down glucose. We need oxygen to break down glucose, and we'll see why later on. So this is the reactant side of the equation, and then we're going to undergo cell respiration, which is going to give us our products that we mentioned before. Remember, catabolism of nutrients will lead to these products. 6 molecules of carbon dioxide, 6 molecules of H2O, and of course energy, we'll say. And energy means ATP and heat. We're not going to get into the specifics of that just yet, how many. That's for another video in this series. But right now, let's break down this equation. First of all, what is the process that's leading to this end result from these reactants? It's of course cell respiration. So it's worth writing down on top of the arrow the process. So this is cell respiration. What we also notice is that these are our reactants. These are the starting components of this chemical equation. And these are then going to be considered what? These are our products. So out of our reactants, through cell respiration, we get our products. And this process, again, is cell respiration, but specifically we get products out of a catabolic reaction. And I'm going to write catabolic reaction. That's going to cause products to be released. Specifically, energy is going to be released because we want to remember this is a catabolic reaction. It's the breakdown of this really famous molecule into these smaller components with the release of energy and also heat. Another thing we want to notice is the idea and sort of label out what's getting oxidized, what's getting reduced, who's the oxidizing agent, who's a reducing agent, etc. So let's do that. So overall, from this equation, we can come out with some facts that you definitely need to know because the exams always ask these type of questions. What can we say about glucose? Which one of these is glucose, first of all? Of course, it's this one, C6H12O6. Glucose is considered the thing in this equation that's being oxidized. Remember, oxidation is loss and reduction is gain of electrons. An easy way to remember that is actually oil rig, and you've probably heard of this in your high school classes. Oxidation is loss, and we can say of electrons on the side in small writing. Reduction is gain of electrons on the side. So I said that glucose is oxidized, so it must have lost electrons. And what did we say hydrogen's role was? Hydrogen was the thing that we're looking for. If something loses hydrogens, then it's oxidized. If something gains hydrogens, it's reduced in the context of cell respiration. So let's look. We have C6H12O6. Let's go on the other side. Where do we see another carbon, let's say? Oh, right there. Okay? So we see C, and look at the 6 over here. C6, that's what it means, 6 C's. And we also see O2, and we have 2 times 6. That's just basic chemistry. That will give us 12. But what's missing here? Of course, that hydrogen. Those hydrogens are missing because glucose was oxidized. Glucose was oxidized. Glucose lost electrons. It lost hydrogens and turned into carbon dioxide. So we can say glucose is our oxidized molecule. Then what's our reduced molecule? Well, let's go back into our equation. Which one of these gained those 12 H's? Those 12 H's have to stay on this side of the equation, but which one of these molecules, obviously by the process of elimination, we see that oxygen, 6O2, actually turned into 6H2O. Look at those 6, so there's 2 H's for every water molecule times 6, gives us 12 H's overall. Remember the 12 H's right here? We just gained those 12 H's right here, because oxygen just was reduced. It got reduced to water. Oxygen was reduced to water. So we can say glucose was oxidized to carbon dioxide because it went from C6H12O6 to CO2, and we can specifically say, let's say 6CO2 just to keep our chemistry in line. And then oxygen was reduced to what? It was reduced to H2O. How many? 6. That's where those 12 H's went. Remember, oxidation is loss of electrons. We lost the H's here. And oxygen was reduced to H2O. It gained those 12 hydrogen electrons in this situation. Another thing we want to note is that this is obviously a catabolic reaction. It's worth emphasizing again because it releases energy. That should be very clear by now. And also, because it releases energy, we can also consider it exergonic, an exergonic reaction, a favorable reaction, a spontaneous reaction. Do we have to input energy? Do we have to input energy in this process? No, we don't. Our cells do it on their own. So we say favorable, and we can also say spontaneous. All of these words describe cell respiration very much so. And overall, so now we have an idea of what's being oxidized, what's being reduced, why it's catabolic. We're now going to look at the exact stages of this process. Specifically, there are 4 stages of cell respiration. We've established an overall chemical equation that proves what's being oxidized, glucose, and what's being reduced, oxygen, and what it's being oxidized to, carbon dioxide, and what it's being reduced to, H2O. And now we're going to look at the 4 stages that give us this very important part of this equation, the energy, the ATP specifically, of the products in the next couple of videos.